Hi everyone. So today in this session, I'm going to take you through the maths behind one of the more popular methods for classification, that is support vector machine. But before we go over there, there are a couple of basic formulas which I would need to derive, right? So that our SVM derivation, right, is 100% bulletproof. Okay. So the first point which I need to take you through is what is the vector, okay, which is perpendicular to any given line. Okay. So we'll need to find this out. And the second thing is what is the perpendicular distance, okay, from a particular point, let's say x0 y0, to a line, okay, to a line. Let's call it as ax plus by plus c equal to 0. Okay, so we would derive these two formulas, and then it would be easy for us to understand SVM, because these are the 2 points which are used, right, in SVM. Many more things are used, but these are at least the basic ones which we should be cognizant of. Otherwise, we won't know that why is it and where it is coming from. Okay, so let's assume this is a line. Okay, the line which is ax plus by plus c equal to 0, and I will need to find the vector which is perpendicular to this, right? So what is that vector? So let's assume there are 2 points. Let's call it as a and let's call it as b. Okay, this point is x1 y1, okay, and the second point is x2 y2. All right, now what is the vector form of ab? Okay, so if you write it, it would be nothing but b minus a, right, or a minus b. So let's call it as, okay, so let's write it x2 minus x1 itself. Okay, x2 minus x1, which was nothing but I cap. Okay, and I cap means in the x direction. All right, y2 minus y1. Okay, so this is the vector notation of the line AB, right? So now what? Now we need to find a perpendicular, the thing which is perpendicular to this. Okay. Also, we know that because these 2 points are lying on the line ax1 by plus c ax plus byc, so we can easily write ax1 plus by1 plus c equal to 0. Okay, this one thing, let's call it as 1, and the other would be ax2 plus by2 plus c equal to 0. Okay, we can write this. Now let's subtract these two. So 2 minus 1, let's do this. So it becomes a x2 minus x1, okay, plus b y2 minus y1, okay, equal to 0. Now here is the trick. Now what we could also write it as a I cap plus b j cap dot x2 minus x1 I cap plus y2 minus y1 j cap, right? So that is the most critical trick over here, right? Because then we will use it to identify the vector which is perpendicular to this vector. Okay, now if you look into this x2 minus x1 y2 minus y1, right, this is nothing but the vector notation for the line AB, right, for this line, for this specific line. Okay, for this specific line, and we wanted to find out the vector which is perpendicular to this. Now as you would know, if two vectors are perpendicular, their dot product a dot b is 0. Okay, if a and b are two vectors and their dot product is 0, that means these two vectors are perpendicular. Now if you look into this, this is one vector which is nothing but this AB vector, right, x2 minus x1, and this, and then we have this ai cap plus bj cap, which means that this specific vector, right, ai cap plus bj cap, okay, this is perpendicular to this specific line, which is nothing but ax, which is this specific line, which is this one, x2 minus x1 I cap, and then y2 minus y1 j cap, right, which is also in another form is ax plus by plus c, right? So we find out that the direction of the vector, right, which is perpendicular to line ax plus by plus c equal to 0 is nothing but a comma b, right? So this is the vector which is perpendicular to this. When I started out, it was a bit confusing, as because I used to get confused as to this is, are these the coefficients, right? So how can this be perpendicular to this line? But as I showed, if you follow this method, then you would easily remember and be very comfortable with the fact that the coefficients of the line ax plus by plus c equal to 0 is the nothing but the line which is nothing but the vector which is perpendicular to that given line. Okay, so this is one thing. Now this was the first thing which we derived, and we derived that what is the vector perpendicular to a given line ax plus by plus c is nothing but a I cap plus b j cap. Okay, this is perpendicular. Alright, now let's find out the perpendicular distance, right, of the perpendicular distance of the line from the point x0, y0 to the line x plus by plus c. So what I'm referring to is, if this is a line, okay, if this is a line ax plus by plus c equal to 0, and this is a point x0, y0, so we are interested in finding out what is the perpendicular distance, right? This perpendicular distance, what is that perpendicular distance? So there are a couple of methods of doing that. If you're not into vectors, then what you would ideally do is find out the equation of the line which is perpendicular to this. So you would know that because you know already this, the slope of this is specific line. So you would take -1 by m if m is the slope of this line. Then you will make it pass to x0, y0, then you will find the equation of the line, then you will make this particular line intersect with this specific line, right? Get this specific point and then find out the distance between these two. So which is a lot of maths, right? And the beauty of vector is that it simplifies a lot of stuff for us. So which is something which we'll see. Okay, sorry. Okay, so let us do this. Alright, so now let's get started on this. So this is a line ax plus by plus equal to 0, and then this is the line x0, y0. Sorry, this is the point. Now let's assume there is a generic point called x1, y1. Okay, this is A, let's call this as C. Alright, now what is the vector notation of AC? Okay, so vector notation of AC is nothing but C minus A, which is y0 minus y1, sorry, not this one. Okay, so it would be x0 minus x1 I cap, okay, plus y0 minus y1 j cap. Okay, now as I had just derived that equation of the vector, okay, which is perpendicular to this specific line, is nothing but, if you look at this perpendicular vector, it would be a I cap plus b j cap. Okay, now if we find this, right, if we do AC dot, okay, forget about dot for that matter. So if we do AC into cos theta, okay, assuming this, so we'll come over here and let's assume this is angle theta. Okay, and if we do AC cos theta, so that would mean that this is the perpendicular distance. Okay, this is that perpendicular distance. Hold on, I think there's some issue with the pen. Alright, so let's resume as to where we had left. My pen was not working, so I had to actually go and then figure out what was the issue. So let's say that this is a line, okay. This is what our favorite line, which is ax plus by plus c equal to 0, okay. Now we are saying that we want to find out the perpendicular distance of this point, okay, from this line. This is what we are trying to do. So let's say this, let's take a point which is A, let's call it as A, okay, let's call it as C here, and then let's make it as x1 and y1, okay, right. So figure out what is the equation of this line, okay, AC. So we figure out what is the equation of this AC. Now imagining this to be theta, okay, now if we can say that AC cos theta, right, then we'll get this specific line, alright. So if we are saying that we take the magnitude of AC and multiply it with cos theta, Alright, then we'll get what we want. Right, the other way of doing that is, let's write it AC, the magnitude of this, into 1 into cos theta is something also we could write. Okay, now the interesting thing is, if it if we know what is the unit vector perpendicular to this, okay, this is specific line, let's call it as n, right? So we could write AC dot n cap. Okay, and cap is nothing but the way I am telling it, it's a unit vector. Then we will get what we need, right? So we will say it is equal to AC magnitude of n, which is nothing but 1 into cos theta, right? And theta is the angle between these two, which is exactly what I showed over here. Theta is this angle, right, which is perpendicular, which is the angle between AC and the perpendicular. All right. So what is the unit vector perpendicular? What is the unit vector perpendicular to this x plus by plus c? And I had shown it to be earlier that this is nothing but, first of all, let's say n cap. Okay, n cap. So this is nothing but ai cap plus bj cap. Okay, and the unit vector would be nothing but what? It would be ai cap plus bj cap, okay, divided by the magnitude of this vector, which is nothing but a square plus b square. Okay, so let's write it over here. So the perpendicular distance would be AC dot n cap. All right, and we know AC is what? We just found out this AC equation, x naught minus x1 I cap. So let's write it over here, x naught minus x1 I cap plus y naught minus y1 j cap. Okay, dot what? Dot, we know the unit vector is nothing but ai cap plus bj cap, alright, divided by a square plus b square. Okay, now let's expand this. So what does this become? This becomes a into x naught minus x1, alright, plus b into y naught minus y1, alright, divided by a square plus b square. Okay, and let's then expand this. Okay, so after expanding this, we get it to be ax naught plus by naught minus ax1 plus by1. Okay, by under root a square plus b square. And over here what we also know, because this point x1 plus y, x1 and y1 is lying on this specific line itself, right? If I write as ax plus by plus equal to 0 and x1 and y1, so let's say x1 y1 is a point on this, so it should also follow ax1 plus by1 plus equal to 0, or ax1 plus by1 equal to minus c. Okay, so you just put this point over here, so which is equal to ax0 plus by0 minus of minus c, which is plus c by a square plus b square. Okay, so this particular formula is gold dust, it's gold mine, right? Might not seem to be very relevant right now, but when we go to the SVM, the entire concept is based on this, right? The perpendicular distance of a point from a particular line. So this ax naught plus by naught plus c is nothing but, again, let me draw this. If this line is ax plus by plus c equal to 0, and this is a point, let's say x naught and y naught, so the perpendicular distance of this specific point from this line is nothing but this. Okay, so I'll stop over here. This was the first part in which I took you through the most basic formulas which are used in SVM. In next phase, I'll take you through the entire derivation of SVM. Thank you.